All right, hello everybody. I'm Mr. Sheldon, and today we're going to be going over the volume of cylinders, cones, and spheres. And so first off, we have the volume of cylinders. So it says a cylindrical stack of coins is shown below. The dimensions of an individual coin are shown as well. If you need to find the amount of space taken up by the stack of coins, how could you use the dimensions of the individual coin to help? So if you have just this itty bitty coin, how could you use this to find the amount of space taken up by all of the stacks of of the coins? And so what you could do is you could find the area of one coin and then multiply it by the total amount of coins. All right, and so we're going to see how that looks. So first off, what is volume? Volume is the amount of three-dimensional space occupied by an object. Volume can also be referred to as capacity. So it's basically saying how much can something hold? And so think about, like, if you were to pour water into this coin, how much water could that coin hold? And so it says, to find the volume of a cylinder, multiply the area of the base by the height of the cylinder. All right, so the formula can be written as V equals BH, and here we can describe each variable. So this V right here, this is just going to stand for the volume of the cylinder. Our capital B, this is going to stand for the area of the base. And so the base is going to be this flat side on each end of the cylinder. It's going to be the flat side on each end of the cylinder. And our H stands for height, or the distance between bases. And so typically you'd see this and you'd think, okay, well, how tall is it, right? So from top to bottom, but not always will it be vertical like this. Sometimes you might have a horizontal facing cylinder that looks something along the lines of this, like it's laying down on its side. Well, the height isn't from top to bottom, it's between the front face and the back face, or both bases. So that's how you can always remember what height is. So then it says, the base of a cylinder will always be a circle. So to find the area of the base, we use the formula pi r squared, just like we use to find the area of a circle, right? So just to see this in action, we have a lot of definitions here. We have V equals BH, where our B is going to be this pi r squared. And we have our H, which is always going to be the height. And so now if we look at number 1, so we have a cylinder here with a radius of 6 inches and a height of what seems to be 4 inches. And so if we plug in our formula is V equals BH, right? So V equals capital BH. Well, we also have to plug in what that B is here. So we can say V equals pi r squared times H. So this pi r squared, that's what that B is. And now we can just plug in the actual values that we have here. And so we have 3.14 because it's telling us to use 3.14 for pi. We have 3.14 times, what is our r? Our r is 6 inches, so it would be 6 squared, because that r squared. And then our height, which is 4 inches. All right, and now if I take out my calculator here, and I put this down, we have 3.14 times 6 squared times 4, and that will give us 452.16 inches. And so that will be our volume. So 452.16 inches. And usually whenever we do area, we'd square this inches, right? We'd square the units. But because we're working in volume, we're actually going to cube it because we're working in a 3-dimensional space, not a 2-dimensional space. All right, moving on now. We'll move on to cones. All right. So for cones, we're going to start here. We're going to go over these examples up top. We're going to go over those in class, so don't worry. But for the volume of cones, it says the volume of a cone will always be 1/3 the volume of a cylinder with the same height and radius. So that's what I was saying, is we're going to go over their relationship in class. We have a good little website we can use to show you that's more visual. So if we keep going, it says the formula for the volume of a cone is V equals 1/3 capital B H. So remember, it's 1/3 and our capital B H, that's our air volume formula for a cylinder that we just went over. Or it can also be written as V equals BH over 3. So it's the same thing as just moving that 3 underneath and dividing the whole thing by 3 or multiplying by 1/3. It's the same thing. So it says, since the base of a cone is a circle, the area of the base is found by using, like we used last time, pi r squared. So now we'll go over this first example. We have a cone here with a radius of 5 inches and a height of what seems to be 12 inches. So you remember how I said it might not always be vertical up to down, the height. So you might not always measure from the lowest point to the highest point. It's kind of like if someone were to measure your height while you're standing, they measure from your toes to your head, right? Or to the tip of your head. But if you were laying down and they needed to measure your height, they wouldn't just measure the heel of your foot to the tip of your toe. They would measure from your feet to your head, like always. So it's the same thing. It's like, just imagine the height is just now laying down. So our formula here, we have V equals 1/3. And then remember what you said we'd plug in for B, it's that pi r squared, like last time, because that's our base. So we'd say pi r squared times H. So now we just plug in these values again. We have 1/3 times 3.14, because it's telling us to use that instead of the pi symbol, times 5 squared times 12, our height. Our height is our 12 inches and our radius is that 5 inches, right? So now we just take out our calculator again. We can do, I think it's math, and then go over to fractions. We can do 1/3 times 3.14 times 5 squared times 12. And that will give us 314. And our unit is going to be inches again. And remember, we're working with volume, so that it's going to be a cubed unit because we're working in that 3-dimensional space. So there's cones. And again, we'll go over more examples in class. Don't worry, this is just like an introduction for you guys. All right, and so lastly here we have the volume of spheres. And so we're gonna skip this middle part. This is gonna be what we're gonna go over on that website, like I said, just to show you guys the relationship between all of the volumes. So we're gonna look up here at these notes first. So it says here, the volume of a sphere can be found by using the formula 4/3 pi r cubed. All right, this is going to be a little weird one you're going to have to remember. It also says that half of a sphere is called a hemisphere. All right. So, skipping all of that, we're going to go down here, and we already have the formula for it, so that's all we really need for the volume of spheres. So now we're going to go down here and look at number 1. And our formula says, what is it? It was V equals 4/3 pi r cubed, right? And so now we just plug in our values. Well, the only value we need to plug in here is that 3.14 because that's what it tells us right here to use. And then what is our R? Our R tells us that it equals 3. So we now have 4/3 times 3.14 times 3 cubed. And now if we take out our calculator, we do math, go all the way over to fractions, hit that first one, do 4/3 times 3.14 times 3. And then we don't have a cubed button, but you can hit this little caret thing. We call it a caret top. And so that will put your cursor up into where the degrees go. And you can plug in a 3 right here for it to be cubed. And then close it with the parentheses. Now if you hit enter, that now gives us 113.04. So 113.04. And we don't have any units, we don't have any inches or anything, so we can just plug in units. And we always cube them when we're working with volume. So that was a little intro. We'll go over more practice problems, and you guys will see it more in detail when you get to class. I hope you guys have a good rest of your day, and thank you for watching.